crystalline solid A contains two
Okay.
cations and one anion?
October, November 2019. Yes, a pale green crystalline solid A contains two cations and one anion. When A is bonded with aqueous sodium hydroxide, a gas is evolved that turns damp red litmus paper blue. Identify by the name or formula the gas. Generally, whenever the litmus paper is going to change its color from red to blue, B for base. Of course,
Yeah,
ammonia gas is released, isn't it?
yeah.
Yeah, ammonia gas is released. Give the name of the or the formula of the cation that is identified by this test. Which test?
A pale
Cation. Yeah, okay.
NH4 plus NH4
Ammonium.
plus.
Yep, ammonium. Yes. Ammonia is released from ammonium. Okay. A dissolves in distilled water to form a very pale green solution B. B reacts with NaOH to form a green precipitate which turns in, oh, this is iron, isn't it? Green to brown is
Hmm.
iron. Iron 2 is green and iron 3 is brown. And then give
Yeah,
the name or formula of the cation in B that is identified by this test. So I'm supposed to write Fe2 plus, right?
yeah.
Identify by name or formula the brown solid C. Of course, it's a solid, so there is no charge. It's an iron 3. That's why it's brown. So I'm supposed to write FeOH3.
Yeah.
B gives a white precipitate when aqueous barium chloride. Of course, whenever after adding barium chloride, we can see the white precipitate. So it's just due to the formation of barium sulfate. Give the name or formula of the anion in B that is identified by this test. So I'm supposed to
SO4 2
write
minus.
SO42 minus. Yep. Suggest the formula of solid A. Now we know the cation and anion. Then we have to write down the overall formula. So I can say in like we have ammonium as well, we have iron as well, we have sulfate as well, right? So
Yeah,
an iron is 2, and iron is 2, so I'm supposed to write 2 and then 2.
yeah.
And also I can write this one. Okay,
Yeah.
a sample of this one, calculate the number of moles of water of crystallization combined with 1 mole of the anhydrous solid.
Calculate the number of moles of water crystallization combined with 1 mole of the anhydrous solid. Okay. The sample of 0.025 moles of solid A. What is solid A? Okay. Okay. The sample of is heated gently to remove the water and leave. Wait. So mass of water is 9.8 minus 7.1, just 2.7 grams. And then
What's the answer?
number of 1 second water crystallization by the volume. Um,
First of all you found the mass of water, isn't it?
Yeah.
Yeah.
2.7.
So that's going to be 2.7. How?
9.8 minus
Like
7.1.
you have to subtract it, right? 9.80
Yeah.
minus 7.10.
7.
Anhydrous and hydrated, of course. When I would be subtracting anhydrous from hydrated, I would be getting the mass of water. Then we have to find out
Hmm.
the mole of water. That's going to be 2.7 over 18. That's the molecular mass. So I would be getting
0.15.
0.15 mole, right? 0.15
Yeah.
mole. And then what's the mole of the solid A? That's going to be 0.025 and it's gonna be 0.15. It's A and it's water. I'm going to divide it by the smallest number. That is this one. So I got one, and what's the answer? It's going to be 15 into
One
25. It's
second.
going to be
1
6.
divided by 0.025 times 0.15. 6. Yeah. 6. Yeah.
Okay, that's the answer. Yes. W is a white solid with the molecular formula C9H8O2. A series of tests is carried out on W. Complete the table. Ignite a sample of W. Very smoky flame. W could be an alkene, or W could be an alkene, or it's supposed to
Uh,
be arene as well. Arene
Irene. Yeah. Yeah.
is when it's a benzene, because on
Yeah.
combustion it gives a sooty flame. Like I can say suits,
Yeah.
black smoke. Yeah. Or add a little W to bromine water. Yeah, if there is an alkene, if there is a double bond, yellow solution turns into a colorless solution. So W contains the carbon carbon double
Ester.
bond, isn't it?
Yeah. Yeah.
Yeah. Yeah. Heat W until it melts. When add PCl5, steamy fumes form. PCl5
OH.
reacts with OH group. Yeah, good. Hydroxyl group. Yep. And then complete the table which contains information about the mass spectrum of W. A peak occurs at mass to charge, that is due to this one. Due to this one. So, of course, what's the, I can
Wait,
say,
sir. We missed the last one.
which one? Heat.
We
Um,
we
uh, oh, yeah, yes, yes, yes. This is like this one.
Yeah.
Heat W until it melts, then add solid. Bubbles of carbon dioxide form. So W contains what?
Not sure.
Bubbles of carbon dioxide. And you know what's W?
Is it
W is
carbonate?
this one. Yeah, of course, it's a carbonate. W is this one, right? C9H8O2. Two oxygen atoms. Two oxygen atoms. Bubbles
Hmm.
of carbon dioxide form. So it's going to react with carbonate. So
Hmm.
it means that when something reacts with carbonate, carbonate is a base, it's going to be an acid. It's gonna be carboxylic acid, right?
Yeah.
Okay, so this is add solid sodium carbonate.
Yeah.
Okay, this one. What's the MR of
Complete
this
the
peak?
table. Sorry. 6 times 12 plus 5 times 1. 77.
77, yep. A peak occurs at mass to charge is equal to 103. This peak is due to the ion with the formula. So what would be 103?
Yeah.
What
C8
would be
at 7
103?
plus. C8 at
C8.
7. At 7 plus. Yeah.
We have to make the fragments. Then we will come to know that what's this. So it
Yeah.
will require some sort of working. Okay. So then the low resolution proton NMR spectrum of W has four peaks, okay, means it has a four different environments, proton environments, each with the relative area 1 and two peaks each with the relative area 2. State the number of protons environments in W. So I can say that has four peaks each with relative area 1 and the two peaks each with the relative area 2. So what do you mean by this? 2 plus 2, then 1 plus 1. It's gonna be 6.
Uh, yeah.
So they are saying has
W
four
X.
with each with the relative area of 1. Each means 2. And two peaks each with the relative
Yeah.
area of 2. So 2 plus 2 and then 1 plus 1. Yep. What can be deduced from the relative peak areas?
Number of protons in each environment, right?
Yeah, there are four environments. There are four environments. Each is having each is having single proton. W exists as two geometric isomers. Okay, use all the information in this question to deduce the structure of one of these isomers. It's a carboxylic acid. This is confirmed because it was reacting with, I can say it was reacting with carbonate
Carbonate. Yeah.
and it has given you the positive test for PCl5 and it may be an arene because it was giving you very smoky flame and it has given you the
Yeah.
positive test for an alkene. Yeah, and
Yeah.
you have eight carbon atoms. So we have to just we have nine carbon atoms and eight hydrogens. Then we have to justify this formula. So this formula suggests that if it would be an alkene, so the general formula for alkene is CnH2n. So the hydrogen is going to be 18, but the hydrogens are 8. We have a very few hydrogen atoms, which suggests that this there is something a ring, because whenever you have a ring, so means
Mm.
that it would be a benzene ring, because the very less number of hydrogens are going to represent that we have a benzene ring. So
Yeah.
and also after drawing the structure we have to justify the peak area, we have to justify the proton environment, right?
Mm.
So what the structure I'm supposed to make?
First benzene ring, and then after
Yeah,
that
first benzene ring.
you
Yeah,
have to
first
draw
benzene
the
ring.
carboxylic acid group attached to it.
How many carbon atoms are there in a benzene ring?
So now one, two, three,
Six.
four, five, six, and then after that
How many carbon atoms
seven.
are
But they're
remaining?
still missing.
Seven,
Still missing.
eight, and then nine.
Yeah. Yeah.
Of course, there should be a double bond. Is there a double bond or
Yeah.
not?
In with the
Why?
yeah with CO. Yeah.
No, 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 no,
Carbonyl,
no, no,
no?
no, no, no. Carbon double bond.
No, because benzene, it's what's it called? A localized, delocalized double bond, right?
So,
So it keeps getting delocalized in each bond,
hmm, then
keeps shifting.
am I supposed to make any double bond over there or not?
No.
We have
Benzene
we
is the
are
double bond.
we are supposed to draw the double bond because it was giving you the positive result for the bromine test. Benzene doesn't react with bromine, remember. Benzene doesn't give you the positive
Hmm.
test for the bromine despite it has a double bond. because the double bonds are
Oh,
delocalized. They are not static. It's not giving. It's not going to give you the positive test for bromine.
okay.
Yeah. So that's the structure.
So this double bond, so benzene has a delocalized double bond, but it will not give a positive result because it is
Yeah.
not static.
Yeah. Exactly. Yes.
Okay, fine. Got it then. One second. Okay. Student uses two methods to determine the concentration of radium 3 ounce alcohol. Method 1 uses titration procedure. 10 centimeter cube of X was titrated with 0.04 acidified potassium manganate 7. The equation of the reaction is okay. Fine. Titer. Okay. Find the titer. Okay.
This is easy, I think, right?
Okay. Yeah, we just have to put the values in. So
Yeah, exactly.
21.1,
So titer is going to be
8.5,
21.1 minus 0.5,
20.6,
20.60. It's going to
20.
be 20.20. It's going to be 19.6 T. And titer used to calculate mean. We have to see the concordant reading, right? In which there is
Yeah, one
in
sec.
which there is a little difference.
That's the
So
20.1 and 20.2.
exactly. So
Yeah,
what we have to do, we have to add it. We have to add these and then divide it by 2. This is going to be the
yeah.
mean
So
titer. This
20.15.
is going to be the mean titer, yeah. So 20.20 plus 20.10 then divided by 2 is going to be, what's the answer? 20.15, like the middle
20.
one, right?
Yeah, yeah.
Yep. Now we have to find out the concentration. For concentration, we need to have mole and volume. I got the volume of V2 plus, right? V3 plus.
Yeah.
Then we have to find out the moles of V3 plus by the given data.
Mm.
The concentration of MnO4 is given to you, right? The concentration
Yeah.
of MnO4 is given to you. So, and oh, in the burette we have KMnO4. Oh, so this is the volume of KMnO4, right?
Yeah. And more for us to come.
So we can find out the moles of KMnO4. After finding out the moles, we can find out the mole of this one. When we would be finding out the mole of this one, the volume is given to you. You can find out the concentration very easily.
Yeah. So N is equal to CV.
Yeah.
N is equal to N is equal to CV 0.02015 times how much was the 0.04? Okay. This is what potassium manganate
Point
is.
zero 0.04
What do they want us to
mm,
find? Concentration of
multiplied by the 20.15.
divided
So
by
mole
2.
of, yeah, mole of MnO4 minus is equal to 0.04 multiplied by 20.15 divided by 1000. It's gonna It's going to be um what's the answer?
Uh, 2.015 times 10 raised to negative 3.
2 point?
Uh,
No.
you, you're asking about the moles of vanadium, right?
MnO4 minus.
Oh, for vanadium I found. Anyways, for MnO4 minus it is 1 second. 8.06 times 10 raised to negative 4.
So the mole ratio between the mole ratio is 2 is to 5, right? This is 2 and this is
Yeah.
5. So I got the moles of MnO4 minus, that is 8.06 times 10 to the power minus 4, and this is going to be x. Then we have to cross multiply this. I would be getting the mole of V3 plus. So that you were saying 2.0 what?
2.015 times 10 raised to negative 3.
So then we have to find out the concentration. That is going to
Yeah,
be
that's
mole.
0.2015 mole per decimeter cube.
What's the volume? I think volume is given. That was
Yeah, yeah,
10
10.
cm cube, right?
Yeah,
10 raised to the power minus 3. It's going to be, what's the concentration?
0.2015.
Each burette reading was accurate to zero point zero 0.05. Calculate the percentage uncertainty in the titer value for the titration 3.
It is 0.50%.
0.50%. How?
No, no, no. Wait, the titer value. Uh, yeah,
It should be multiplied by 2 because this is a burette. We have to take the
yeah,
initial and final reading, and then we have to take the titration 3 value, that is going to be 20.10. That is going to be
yeah. And
20.10. So we have to divide this by 20.10. So I would be getting,
you need to multiply by 100 also.
yep, they're asking the
Yeah, and
percentage.
then I got
What's the answer?
0.5%. 0.5.
Okay, method 2 used an electrochemical cell. It's a complete the diagram by adding labels on the dotted lines provided conditions are not required. It's going to be voltmeter.
Yeah, high
It's going
resistance
to be,
voltmeter, then platinum electrode,
yeah,
and then after that zinc electrode, and then after that is it 1 mole? I don't remember. 1 mole per decimeter cube of H plus
yeah, is the
ions
yeah,
from
that's
HCl.
the standard condition. That's the standard condition. Solution of Y containing V2 plus and V3 plus. So it's going to be which electrode I'm supposed to use? Platinum, right? Isn't it?
Yeah, and then the other one
Whenever we
is
have
zinc.
two ions of a different two ions of the same element, so then we have to use platinum electrode. And then what about
Yeah,
this one? Then what about another one?
is that
So of course we are supposed to have zinc, solid,
yeah,
and then solution of zinc 2 plus.
Zn2
That's
plus.
it. The
The
salt
salt
bridge
bridge
consisted
consisted
of
also
a strip of filter paper soaked in a saturated KNO3. Okay. Give a reason why potassium hydroxide solution should not be used for the salt bridge. Why?
not it is not uh, as soluble as KNO3.
Or first of all, why do we use
Yeah.
salt bridge? First of all, why do we use salt bridge? Why?
To transfer the ions, sorry, to transfer the electrons,
To transfer
right?
the electrons, okay, to complete the circuit, isn't it? To complete the circuit, am I
Yeah.
right? So basically,
Yeah.
when you will be using when you will be using potassium hydroxide in the salt bridge, so basically potassium hydroxide can form a precipitate with the zinc. It would be forming zinc hydroxide. It would be forming
Yeah.
zinc hydroxide. Of course, zinc hydroxide is a solid. It can form a
Hmm.
precipitate. And once the precipitates are formed, so there will be a blockage in the salt
Yeah.
bridge. Okay, so then the circuit will not be completed. So then the current will not flow. So that's why we are supposed to take night. All nitrates are soluble. All nitrates are soluble. That's why. So 1 mark. So I'm supposed to write. Uh, it can form like KOH will form PPT. Okay, with the
Yeah.
given cation. In this cell, the zinc half cell was at standard temperature and concentration. When the cell reaction occurred, the zinc was oxidized and E of cell is 0.144 volts. Write the overall equation for the cell reaction. State symbols are not required. Then
Zinc was oxidized. Okay, fine. Zn. That means that V3 plus E minus.
basically we have to see what's going on. V2 plus and V3 plus, right? V3 plus and V2 plus, it's a mixture of two ions, and then we have a zinc one, right? So this like these equations are given to you, right? Zinc 2 plus is going to gain 2 electrons and it's going to form zinc, and V3 plus is going to take 1 electron and it's going to form V2 plus. So then what we have to do, we have to cancel out electrons. But the thing is that in the both equations, the electrons are on the left hand side. So we have to flip one of the equations so that we can cancel out electrons on the opposite sides. And then after cancellation of electron, then we
Yeah.
have to add the two equations together. Then I would be getting the final cell equation. So which equation I'm supposed to flip? And of course,
The
we have to
Zn one.
multiply that equation by 2 because in the first equation we have 2 electrons, right?
Yeah.
They have given you the overall cell
ZdZ.
value. Ah, sorry, yeah. E of cell is 0.44.
Yeah. So I got Zn plus 2V. 3 plus gives Zn2 plus 2V2 plus.
Which equation did you flip and why?
Which I flipped the first one because it's getting uh reduced, right?
It's getting is the second one
Sorry,
equation
first
is
one,
also
sorry. First one is getting oxidized in reality, so
how?
I flipped it.
How
You
it's
said
getting
that it's getting
oxidized?
oxidized.
Yeah. So they are saying the zinc was oxidized, and oxidation is the loss of electron. So Zn is going to convert into Zn2 plus after losing two electrons.
Hmm.
And then I have V3 plus. Cancel. The standard electrode potential for the zinc 2 plus and zinc half cell is minus 0.76. Calculate the electrode potential for the V3 plus and V2 plus half cell in this experiment.
Hmm.
The one they have given to you, that is 0.44, positive
Yeah.
0.44, right?
Hmm. So you first have to take this is standard electrode potential. Okay. Yeah. So okay, it was not
It's
at
for the
standard constant.
zinc 2, yeah.
Yeah. So then what you have to do is 0.44 minus 0.76.
What?
0.44
Overall
minus
cell potential,
minus.
like you are saying that E of cell is equal to uh,
Okay, sorry.
oxidation minus reduction.
E cath minus E
So E of cell is
cathode minus anode.
0.44. We have to calculate this one. This is given to us, that is 0.76. Reduction minus oxidation, sorry. It's reduction
Yeah.
minus oxidation. So we have to, oxidation value is 0.76. It's negative already. And this is we have to find out.
Mm-hmm.
So it's going to be, so the answer is negative 0.32, right?
Yeah.
Yes, see this?
Hmm. And then electrode potential E for the V3 half cell. Okay. Solution Y was one more per decimeter cube with respect to V2 plus. For the half cell of the in the experiment, the electrode potential was given by. Okay. Use this and the answer to be. Okay. So is the concentration 0.36 mole per 361 moles per decimeter cube?
Mole, what's the concentration?
0.361 mole per decimeter cube.
0.361.
Yeah.
Mm, You are telling me the concentration of V3 plus, right?
Yeah.
No.
Wait, first what you have to do is where E is the value we already found before, right?
Yeah, that is 0.32 negative, right?
Yeah, so negative 0.32
Is equal
plus
to
0.26.
plus y plus.
I mean, like I just shifted the
Oh, okay,
E
okay, okay.
minus to the other side.
So they have given to us that is negative 0.26 plus
Mm-hmm.
0.059 into log.
Mm.
This is we have to find out,
Yeah.
right? X. So negative
Yes. So
0.32 plus 0.26 is equal to 0.059 into log x. Then we have to divide this by 0.059. What's the answer for this one?
uh which one? I directly did. I did negative 0.32 plus 0.26 divided by 0.059. And I got that as negative 1.0169.
Like that.
Yeah.
And you have taken 10 to the power.
It's not. Oh, this is not a natural log. Sorry. That's why I went wrong. I thought it was
Yeah.
ln. My bad.
It's log
Okay,
10.
now I know where I've gone. Yeah, I thought it was this thing. Um, natural log. Sometimes they do that also. No, so I got confused. Yeah, 10. Yeah, then okay. I got 10 raised to answer. 0.0962. Final answer.
Final answer is 0.
0.962. The concentration of V3 plus is approximately double that obtained in B5.
See this one?
Yeah. Explain why these two values are different. One was done under standard conditions and one wasn't. No, but the other one is
Okay.
titration. No. That's wrong. That's wrong. I don't think that's sensible argument.
In A part 2, that was this. That was
Titration.
this.
No. This
It's
is B
B
part
part
two.
2. Oh,
Yeah,
so
so
I
this one.
got
What
this.
did I- Yeah.
And the one when we have calculated this one, so we are getting this. So why they are different? Is this lower or higher from the previous one?
Lower.
Lower. What do you mean by this? The concentration becomes lower. If you remember, the volume and concentrations are inversely proportional to each other. When the volume becomes higher, so the concentration becomes lower. It's of 1 mark only. So basically, in the previous one, they were adding the mixture of V2 plus and V3 plus. If you have noted this one,
Yeah.
so The thing is that when they are doing so, so basically the volume will be doubled because we have the same volume of V2 plus and same volume of V3 plus. So the volume will be doubled. When the volume is doubled, so it's mean that the concentration becomes lower. That's why we are getting the lower answer. Okay.
Yeah.
So solutions are mixed with equal amounts. With equal amounts. So equal amounts
Yeah.
means that uh, equal amounts means that uh, the volume is doubled. So concentration becomes lower. Okay, see this one.
Is it NaNO2 plus HCl and more than less than 10 degrees Celsius?
Uh, in step one, the preparation phenylamine is converted into benzene diazonium salt. Give the reagents and conditions for step number one. Yeah, yes, yes. So it should be sodium nitride like NaNO3, NaNO2,
Yeah. Plus HCl
NaNO2 plus HCl.
and 0 to 10 degrees Celsius.
0 to 10 degrees Celsius, right? Okay.
Yeah.
In step two, what's going on in step two? Diazonium salt is converting into the iodine. Okay. In step two of the preparation, aqueous potassium iodide is added slowly to the reaction mixture from step one. The mixture is left to stand for 10 minutes and then it is heated for 20 minutes. The iodobenzene formed is steam distilled from the mixture. Suggest a reason why the aqueous potassium iodide is added slowly. Why? Why it's added?
So that the
Why
reaction
it's
is
added slowly?
so that the reaction is less exothermic.
Oh, so right now, what the reaction is? Right now, what the reaction is? Basically, the preparation of this one is exothermic reaction, right? Okay.
Yeah.
And also we can say that whenever we are going to add something slowly, so it's mean that to prevent like if previously the reaction is vigorous, it's a faster
Yeah.
reaction. Okay. So to prevent further explosions, to prevent the further we can say the vigorousness, we have to add something in a lower, like we can say uh, to prevent a vigorous reaction, I can say we are going to add potassium iodide is slowly. Okay,
Hmm.
so
Yeah.
what I'm supposed to write?
So
Reaction,
that the reaction is less exothermic and less vigorous.
yeah, reaction is vigorous. That's why we are going to add potassium iodide in a slower manner. Okay. Oh my God, this is so much easy. What is A? What is A?
Phenylamine.
It's a liquid, right?
Phenylamine. Yeah.
Uh, anti-bump. No, 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 no. Anti-bumping granules are in B, in not A. So A means this is going to be water.
Oh yeah. Okay.
And in B, we have a anti-bumping granules. It's a reaction mixture. It's a reaction mixture. We are not supposed to mention the names. It's a reaction mixture. It's a reaction mixture.
Yeah.
And what's C? C is
Water out.
I can say water out. Yeah.
Yeah. And then
And
water
this
in.
is in.
Yeah.
State the purpose of the apparatus labeled E. Ah,
Release pressure buildup,
good.
right?
Yeah. Yeah.
Distillate collected contains iodobenzene and water. Iodobenzene and water. Describe how iodobenzene is obtained from the distillate. Um, transfer. Refer to the data given at the start of question 4. What is at the start? Using two steps. Okay. You can just say transfer to um, separating funnel, right?
Iodobenzene and water. Distillate contains iodobenzene and water, right? So describe how
Yeah.
iodobenzene is obtained from the distillate. So both are liquids.
Uh,
Both are liquids.
yeah, but we can transfer to the separating funnel because one is an organic and one is an aqueous.
One is having a lower density, another one is having a higher density, isn't it?
Yes.
So they will be forming a layer. They are insoluble in each other. They are
Yes.
insoluble in each other. So that's why we are going to convert this into a separating funnel. And once the
Yeah.
layers are formed, then you can separate the layers very easily. It's of 2 marks.
Yeah.
So add in
The next one is anhydrous calcium chloride.
separating funnel. Separating funnel. The layers are formed.
Yeah.
Layers are formed. So collect collect iodobenzene in a lower layer.
Yeah.
It's an organic compound, that's why. The iodobenzene obtained from the distillate is a cloudy liquid. Okay. Name a substance that should be added to make the liquid clear.
Anhydrous calcium chloride.
Why?
It is a what's it called? Dehydrating agent.
It may contain some sort of water. It's not a pure compound. It may have some sort of water. So we have to separate the water from this to make it pure. So we have to add, you can say, drying agent. Yeah. So, but we have to mention the name. We have to mention the formula. So I'm supposed to write, yeah, anhydrous calcium chloride.
And then next one I told 185 to 190.
The clear liquid is distilled to obtain pure iodobenzene. Give a suitable temperature range for collecting the pure iodobenzene. Refer to the data given at the start of question
Okay.
number 4. Oh my god, okay. Question number 4. Okay, molar mass, then density, then we have a boiling temperature. Okay, so what they are asking, the clear liquid is distilled to obtain pure iodobenzene. Okay, give a suitable temperature range for collecting the pure iodobenzene.
185 to 190.
Why?
Because the melting point was 188, so we need to be 4 to 5 degrees within the range.
The boiling temperature is 188 and we have to boil it, right? We have to
Yeah,
boil it,
so
isn't it? So
185 to
that it can,
190.
yeah, it can be distilled. Yeah. So I'm supposed to write what? 188 to
185 to 190.
yeah. Yeah, we have a range. Okay, that's it. Now see this
Last
one.
one.
The preparation and purification process has an expected yield of 70%. Calculate the volume of phenylamine needed to produce this one. Yes.
Refer to the data given at the SOMAC. Okay. Density. Oh, so now wait, what is the question? Okay. So can you just go up to the beginning of the question so I can just write it down? The question for data. Sir? Yeah.
Data is this one. Yeah. So yes, density
Yeah.
is given to you, molar mass is given to
Okay.
you, boiling temperature is given to you.
Iodobenzene, okay, and then phenylamine, okay. So iodobenzene mass, iodobenzene mass, phenylamine mass. Iodobenzene mass is, wait, density is equal to mass of volume. Mass is equal to density times volume. But wait, what do they even want? What do we need? We need the, can we even know? We can't, wait, no, we can find the concentration. Yeah.
We have to find out the volume of
So
phenylamine needed to produce this one.
yeah, but we cannot find the moles directly. We have to first find the uh, concentration because you cannot find the mass also. So can you go up 1 second?
So first of all, it means that we have to find out the mass of iodobenzene, right?
But we can't find the mass, no?
Because density is given to you. We can. You
Oh
can see
yeah, my bad,
this.
my bad. Yeah, yeah.
So density of iodobenzene is 1.83, isn't it? Density of
Yeah.
iodobenzene is 1.83 and the volume is given to you. So 1.83.
45.75.
45 what?
0.75. And then the moles is
So mass of iodobenzene is equal to 1.83 times 25, right? What's the answer?
yeah. I got the moles as oh sorry, mass is 45.75, moles is 0.22437.
And the mole of divided by what's the MR of iodobenzene? They have given to you.
203.9. 203.9.
Okay. So the answer is 0.22, right?
0.22437, yeah.
437. Okay. This is the mole. And then
Yeah. And then we need to find the mass of no, we need to find the moles of phenylamine, and the moles will be
they have given
this
you the
thing
equation.
0.5%.
Iodobenzene and
Sorry,
phenylamine, right? They
0.7.
have given you the equation. They have given you the equation in which there is a phenylamine and iodobenzene. So the mole ratio is 1 is to 1. So this is the mole of iodobenzene. This is the mole of iodobenzene. Then it would be the mole of phenylamine as well, right?
No, it will be this thing. Uh, 70% of something gives 0.2247. So that
Yeah,
something
then we
is the
have to
moles of
see they
phenyl.
have given you the percentage. Yeah.
Yeah,
So we have to find out the
0.22437
70% of
divided
this one.
by 0.320528.
Multiplied by 70%, right?
0.320528.
So what's the answer?
Divided by
0. Point,
70%. Divided because it'll be divided by 70%.
mole of
Because
phenylamine we know that
iodobenzene
is
is the product.
0.22437. Yeah, exactly. This is the reactant side. Good. So we have to divide it by the 70%. So what would be the answer?
0.320528. 0.320528. No, so 0.320528. Yeah,
0.32.
correct. 0528.
0528, right?
Yeah.
It's the mole of phenylamine. Okay. And what they are asking, the volume. Okay, we got the mole. We got the mole. And then they have given you the density of phenylamine, that is 1.02. Right. That is
Yeah.
1.02. So what we are supposed to do now? We
Now,
have to find out the
you have
volume.
to
That
take the
is going to
mass
be
which we found. Yeah. We need to find the mass first. So the mass is 0.320528 times
multiplied by its
93.
MR.
Yeah, 29.809. And then
That is
29.809 we need to divide by the density, which was, I don't remember, let me check. Uh,
2, 1.2, 1.02
1.02. Yeah,
grams per centimeter cube, right? Grams per
yeah.
centimeter cube
So the
divided
20.
by, no, we have to basically the thing is that density is equal to mass upon volume, and we have to find out the volume which
Yeah,
is gonna equal to mass upon density. Mass is given, that is
yeah,
29.809 divided by the density, that is 1.02. So I would be getting the volume, that is 29 point something, I think so. 29 point
yeah.
what? In centimeter cube.
29.2. Yeah,
Centimeter cube. Okay.
yeah,
So that's it for this paper. And then we have to
yeah.
start another one.